Today's lesson is on simplifying radicals. I actually taught this in class, doing several examples for a couple of days, but I wanted you to have something online in case you wanted to reference it, as this will be on benchmark 3. So let's go ahead and look at it. A radical is the root of a number. So numbers whose square root is an integer are called perfect squares. For numbers and monomials that are not perfect squares, we just simplify the radical. A radical is in its simplest form when none of the numbers under the radical are perfect squares. You see the square root of 169 is 13 because it's a perfect square. The square root of 32 we break down into 16 times 2. Since 16 is a perfect square, that gets out of the radical, and our simplified answer is 4 radical 2. Here are the steps. Please write them down. So I'm going to circle the numbers that appear twice in the prime factors here. So it looks like I have 2 3s and 2 5s. Well, 3 times 5 is 15, so let me try 15 squared. Okay, so I factored down my number. I find the largest perfect square that is a factor of 450. In this case, it's 225. So then I say radical 2 times radical 225 is going to equal 15 radical 2. Variables with exponents can also be perfect squares. Any variable with an even exponent is a perfect square. To find the square root of an exponent, you just divide by the power of 2. If the exponent on your variable is odd, you go to the biggest even number. So in this case, m to the 15th. We'd split it down to m to the 14th, the biggest even number inside 15. M to the 14th times m, and then the square root of m to the 14th is m to the 7th. Radical m is your simplified answer. you see again, we took out the biggest even number, and then we just left the single a under the radical. I'm underlining the perfect squares in red, and they're coming out from the radical. So remember, when you do this, it's a little easy to get confused between numbers and variables. You square root your numbers and you divide your variable exponent by 2. Please try this one at home.